In physics, the word work has a very specific definition. It's not about going to work or working out. Whenever a force moves a distance, that's work. So anytime you have someone put a force on an object, and then that object moves a distance, work is done. And that's the definition of work in physics. This can apply whether the force and the distance are in the same direction, or even if they're in slightly different directions. We'll cover both of those things in tonight's videos. But the thing you need to remember most of all is when a force moves a distance, work is done. You should have that phrase memorized and tattooed somewhere on your arm so that you never forget it. When dealing with work, you have to be able to figure out whether it's positive, negative, or zero intuitively. You can't just do it mathematically always. You have to be able to look at a situation and say the work there is positive, negative, or zero based on what's going on. So let's take a look at 3 examples where I'll tell you whether the work was positive, negative, or zero. First off, if the force is in the same direction as the way the object moves, then work is positive. For example, if we had a force that pushed a book along a table in the same direction as the force, that would be positive. So imagine pointing your fingers, index fingers on your hands. One is force and one is distance. If they point in the same direction, one is force and one is displacement, if we're dealing with direction. If the force and the displacement point in the same direction, the work is positive. Now, if the force and the displacement point in opposite directions, the work is negative. So for example, if I were taking a book in my hands and lowering it to the floor, my hands supply a normal force upward, but I'm moving the book to the floor downward, so I'm displacing it downward. The force, the normal force, and the displacement downward are in opposite directions. Opposite directions with force and displacement mean negative work. And then, if the force and the displacement are at a right angle, that is zero work. So for example, if you're walking a dog and it's standing right beside you and you pull the leash slightly upward as the dog moves forward, up and forward form a right angle, so zero work is done. And remember, this is the physical definition of work. When a force moves a distance, work is done. When a force and the displacement are in the same direction, that is positive work. When the force and the displacement are in opposite directions, that's negative work. When the force and displacement are at right angles, that is zero work. Those 3 facts you also just need to have memorized, ready to come in, spout out, solve problems, looking at situations. You just need to know this down cold. There's not going to be a lot of redoing these 3 facts. They are facts that you should have memorized when you walk in tomorrow. Well, now that you've memorized those 3 facts, or if you haven't, do so right now, try these 3 examples. Would I do positive, negative, or zero work if and then there's 3 examples on the bullet points. Pause the video, write down what you think each example would be, positive, negative, or zero work, and then come back and I'll talk you through the answer. So pause the video and try them now. Hopefully you paused the video and tried these examples. Now let's talk about them. I'm going to do some color coding. Let's call the forces blue, and I'll do all of my displacements in green. Delta x will be, looks like an E, in green. Alright, first of all, I lifted a 200-pound weight from the floor to waist level. Well, if I lifted the 200-pound weight, as I was lifting it, my hands supplied a normal force upward. And the thing that I moved from the floor up to my waist, so that would be a displacement upward. And if force and displacement are in the same direction, the work is positive. Now I moved a weight from one side of the gym to the other. So if I was carrying the weight, my hands supplied a normal force upward, and I moved it from one side to the other, that would be side to side, either left to right or right to left. The force and the displacement would then form a right angle, and the work would be 0. If I held the weight above my head for 30 minutes, I would be supplying a normal force upward, but there would be no displacement. You must have both a force and a displacement if you refer back to that original definition. When a force moves a distance, work is done. So there was a force, but it did not move a distance. No distance moved, therefore no work was done. And that goes back to the original definition from that first slide. All right, you need to understand all these examples, all the definitions I've given. In the next video are some mathematical problems involving work, and I'll show you how to solve those.